Kinematics, a word coming from the prefix kine, which you can see, which means motion. So we are looking at the motion of objects. But I want you to think about this before we can even talk about or agree about how to talk about and discuss the motion of an object. We have got to establish a method of discussing position, where objects even are in three-dimensional space. Where are things out there in the world? For example, let's say that you, look how beautiful and handsome you are over here on the left, and your friend over here on the right. Let's say that you're both hungry and you have discovered the location of a sacred burrito delicioso right here in the middle. Now, if you guys are friends and you're talking about trying to figure out how to share this thing, you want to figure out how to get to it, where it is located, how you need to move yourselves, position yourselves to go get this burrito. I know this is a very silly example because these are things that we do automatically anyway, but I just want you to think, from your perspective right here, the burrito is in the front and to your left, because you're facing this way, you're facing down, in front of you and to your left, but to your friend, the burrito is behind them and to the right. So, very strange, you guys cannot actually agree about where the burrito is. Whose perspective wins? Should your perspective win? Should your friend's perspective win? I hope you can see that in order to talk about where this sacred burrito delicioso is, we have got to establish something that is known as a reference frame, a way of discussing intelligibly about where things are located, what the position of objects are in space, so that we can all agree on it. Typically, in order to establish a reference frame, we use one of these bad boys here, a coordinate plane. You can see the familiar y-axis, x-axis, but even then, there can be some disagreement. And the disagreement can all be thought to be centered around who is located right here in the middle at point 0, 0. That point is known, hopefully you guys are aware of this already, as the origin. Origin is 0, 0. If you don't remember, these are coordinate pairs. That first number is where we are on the x-axis, and the second number here is where we are on the vertical y-axis. So, should the origin, should the 0, 0 be from your perspective, your friend's perspective? Should it be somewhere in between? So, I hope you can see that in order for us to talk intelligently about where things are located in space, where the burrito delicioso is located, we not only need to establish a reference frame, a coordinate plane to talk about coordinates, location, position in space, but we've also got to be able to talk about origin. Where is the 0, 0 point going to be defined? All right, so we have our coordinate points established. You up here at the top are at -4, 6. Your friend is at 3, 0, and the burrito is at 0, 3. That's what these next slides are kind of getting at. Back 4, up 6 from the origin. Your friend is over 3 from the origin. The burrito is up 3 from the origin. And so we can get those coordinate points that we discussed earlier. So this is two-dimensional, as I said before, kind of back and forth, left and right. But in this class, we're going to make things even simpler. And we're only going to be analyzing motion and position and things like that as if it is on a single dimension. So I'm going to condense our little coordinate system here down into just a number line. So to talk about position, it becomes very, very easy. We now just have to look at a number line. And we call that position, very, very important, because I do not want you to get confused later, we call the position x. And so if I want to talk about my position, x equals -4, your position, or your friend's, whatever, is over here at x equals 3, and the burrito delicioso is at x equals 0. Notice I also have units of measure. You should have read about that already. The SI unit for distance or length is the meter. So we could say this is calibrated in meters. So I am back here 4 meters before the origin, which is now the burrito delicioso. Of course, we would establish that as our origin, it being the most sacred object in existence. And you over here are 3 meters in front of the origin. We're using the negative sign here to represent anything that is to the left of, or you could say behind the origin. And these little hidden positive numbers here are representing anything that is to the right of or in front of the origin. So very, very important. Already we're seeing that we can denote things like direction. Which way from the origin? 4 meters to the left, -4. 3 meters to the right, +3. So left and right are now denoted mathematically with a sign, with positive or negative. You begin your journey 4 meters behind the origin, we know that. You travel to the origin to retrieve the burrito delicioso, and then you take it to share with your friend, whose position is 3 meters in front of the origin. How far has you traveled? It's a pretty simple question, right? You, my friend, have just traveled forward 4 meters to grab that delicious burrito, and being the wonderful friend you are, you're going to share the sacred object with your friend. So you travel forward 3 more. I think you can see very clearly that you traveled 4 meters to the right to get to the origin, and then you traveled 3 more meters to get to your friend. And so very simply, you could have done this in the first grade, you've traveled 7 meters. Pretty simple, right? We could talk about that 7 meters that you traveled back up here. We could call it the distance that you traveled. Distance is a method of discussing how far an object travels by analyzing the total length of the path. So the total path length that you just traveled, forward 4, then forward 3, was 7 meters. But there's another way, displacement. It's a method of discussing how far an object travels. This time we're not worried about the path length. We're not worried about how many times a person turns around, if they go left or right, how many different squiggles and stops and starts and turns and spirals they have in their path. This time we're only worried about 2 things, the starting position and the final position. And you can see here that displacement has an equation that goes with it. Let me talk to you about this little symbol right here in case you're not familiar with it. That triangle is called delta. It's a Greek letter, delta. That's how you pronounce it. And it literally just means change in. You're going to see that again and again and again in this class. Delta means change in. Well, remember the definition of displacement, the change in position. How did the object's position change overall? We're not worried about the total length of the path, that's distance. We're just worried about the change in position overall. So this delta x right here literally means, remember we said that we're going to use x to talk about position. It literally means the change in position, delta x, is equal to, well, how do you find the change in anything? If you are, I have a 4-year-old son, so we're tracking his growth all the time. We know we have a little growth chart on the wall, etc., etc. Well, if I wanted to know his change in height through 1 year, what would I do? I would have my growth chart on the wall. That would just be like my reference frame, right? And maybe at the beginning of the year, I marked he was here at 36 inches. At the end of the year, we marked up here at 40 inches. If I asked you, how much did he grow? What is his change in height? Maybe I could write that down as delta H, the change in height. Very clearly, you know the answer right away is 4. He grew 4 inches. His change in height was +4. I hope he's not shrinking. I hope it's not a negative number. If you get a negative change, that means you've gone backwards. So the delta H is +4. Well, how did you get that? Well, you got the height that he ended up at the end of the year. Maybe we could call that his final height. Do you see how I added an F down here as a subscript to that H sub F? And you subtracted, where did he begin? H with a subscript of I, initial height, final height minus initial. Well, you guys are going to see that in order to find the change in anything, it's always going to be the final variable minus the initial variable. And that's exactly what we're doing here when we find the change in position, the displacement. We're taking the final position and we're subtracting from it the initial position, final minus initial. That is how you will always, always, always find the change. So now using both of those definitions of how far, I think that we are able to very quickly and easily analyze this question in two different ways. How far did he travel? Well, if we wanted the distance, we know that we would just add up the total path length. He went backwards 3, got the burrito, went backwards 4, shared it with you, went way up here to 4 meters in front of the origin. 3 plus 4 plus 8 is 15 meters. That's always going to be a positive number. You'll never have a negative distance. But then there's another way of talking about it, and that is simply to discuss the displacement, the delta x, the change in position. Well, his final position was here at 4 meters in front of the origin, positive 4. His initial position was here at 3 meters. So his delta x, we would say, is 1 meter. His displacement is 1 meter. Distance is total path length, always positive, never negative. Displacement is final position minus initial position, and it can, in fact, be negative. When do you think the displacement would be negative? Yeah, it's going to be if the final position is in front of the initial position, if somehow overall the person traveled backwards. Let's look at this quick example. Let's say that I wanted to analyze this motion of this. I guess, is that a skier, hockey player? I don't know. I don't sports, you guys. We're not worried about time right now, so I'm going to ignore that. We're going to bring that in a little bit later. But let's say that I know that this skier, hockeyer person is starting at position A and is moving all the way to position D. Let's say I wanted to know how far this person went. Well, you guys know right away there are two ways of talking about that. The distance and the delta x, the displacement. I will let you guys check your work on this one. You can see that to find the distance, the total length of the path traveled from point A all the way over to point B, back to point C, then forward to point D. You can see there that the answer is 420 meters. That is the total. The displacement is change in position. You can see the initial position is marked there as the origin, 0. And we're not worried about anything in between. We're not worried that the skier went to B and then back to C and then to D. We're just worried about final minus initial. So the final position is position D, and that looks like it's at 140 meters. So final position minus initial position, 140 minus 0. The delta x, the displacement, should be 140.